Hello, students. For today's reading, we will be reading the article titled Independent and Dependent Variables. Which is which? Independent and dependent variables are very important for both math and science. If you don't understand what these two variables are and how they differ, you'll struggle to analyze an experiment or plot equations. Fortunately, we'll make learning these concepts easy. In this guide, we break down what independent and dependent variables are, give examples of the variables in actual experiments, and explain how to properly graph them, and discuss the one other important variable you need to know. What is an independent variable? What is a dependent variable? A variable is something you're trying to measure. It can be practically anything, such as objects, amounts of times, feelings, events, or ideas. If you're studying how people feel about different television shows, the variables in that experiment are television shows and feelings. If you're studying how different types of fertilizer affect how tall plants grow, the variables are types of fertilizer and plant height. There are two key variables in every experiment: the independent variable and the dependent variable. The independent variable, what the scientist changes or what changes on its own, and the dependent variable is what is being studied / measured. So in other words, in our fertilizer experiment, the type of fertilizer we actually provide would be our independent variable, and our dependent variable would be how tall those plants are actually growing from the fertilizer. The independent variable, sometimes known as the manipulated variable, is a variable whose change isn't affected by any other variable in the experiment. Either the scientist has to change the independent variable herself, or it changes on its own. Nothing else in the experiment affects or changes it. Two examples of common independent variables are age and time. There's nothing you or anything else you can do to speed up or slow down time, or increase or decrease age. They're independent of everything else. The dependent variable, sometimes known as the responding variable, is what is being studied and measured in the experiment. It's what changes as a result of the changes to the independent variable. An example of a dependent variable is how tall you are at different ages. The dependent variable height depends on the independent variable age. An easy way to think of independent and dependent variables is when you are conducting an experiment, the independent variable is what you change, and the dependent variable is what changes because of that. You can also think of independent variables as the cause and dependent variables as the effect. It can be a lot easier to understand the difference between these two variables with examples. So let's look at some sample experiments below. Examples of independent and dependent variables in experiments. Below are overviews of 3 experiments, each with their independent and dependent variables identified. Experiment 1. You want to figure out which brand of microwave popcorn pops the most kernels, so you get the most value for your money. You test different brands of popcorn to see which bag pops the most popcorn kernels. The independent variable of this experiment would be the brand of popcorn bags. It's independent variable because you are actually deciding the popcorn bag brands. The dependent variable is the number of kernels popped. This is dependent variable because it's what you measure from each popcorn brand. In experiment 2, you want to see which type of fertilizer helps plants grow fastest. So you add a different brand of fertilizer to each plant and see how tall they grow. Here, your independent variable is the type of fertilizer given to the plants, and the dependent variable is the plant height. So where do you put independent variables and dependent variables on graphs? Independent and dependent variables always go on the same place on graph. This makes it easy for you to quickly see which variable is independent and which is dependent when looking at a graph or chart. The independent variable always goes on the x-axis, or the horizontal axis. The dependent variable always goes on the y or the vertical axis. Here's an example of that. You can see that time is our independent variable, and our score exam is our dependent variable. That is what we are measuring based on the amount of time studied. As you can see, this is a graph showing how the number of hours a student's study affects the score she got on an exam. For the graph, it looks like studying up to 6 hours helped her raise her score, but as she studied more than that, her score dropped slightly. Maybe that was due to her not getting enough sleep. The amount of time studied in independent variable is the independent The amount of time studied is the independent variable because it's what she changed. So it's on the x-axis. The score she got on the exam is the dependent variable because it's what changed as a result of the independent variable, and it's on the y-axis. It's common to put the units in parentheses next to the axis titles, which this graph does. There are different ways to title a graph, but a common way is independent variable versus dependent variable, like this graph. Using a standard title like this also makes it easy for others to see what your independent and dependent variables are. Are there other important variables to know? Independent and dependent variables are the two most important variables to know and understand when conducting or studying an experiment. But there is one other type of variable that you should be aware of: constant variables. Constant variables, also known as constants, are simple to understand. They're what stay the same during the experiment. Most experiments usually have one independent variable and one dependent variable, but they will all have multiple constant variables. For example, in experiment 2 above, some of the constant variables would be the type of plant that is being grown, the amount of fertilizer each plant is given, and the amount of water each plant is given. When each plant is given fertilizer and water, and the amount of sunlight the plants receive, the size of the container each plant is grown in, and more. The scientist is changing the type of fertilizer each plant gets, which in turn changes how each plant grows. But every other part of the experiment stays the same. In experiments, you have to test one independent variable at a time in order to accurately understand how it impacts the dependent variable. Constant variables are important because they ensure the dependent variable is changing and only because of the independent variable, so you can accurately measure the relationship between the dependent and independent variables. If you didn't have any constant variables, you wouldn't be able to tell if the independent variable was what was really affecting the dependent variable. For example, in the example above, if there were no constants and you use different amounts of water, different types of plants, different amounts of fertilizer, and put the plants in windows that got different amounts of sun, you wouldn't be able to say how fertilizer type affected plant growth because there would be so many other factors potentially affecting how the plants grew. Here's a quick summary of independent versus dependent variable. Knowing the independent variable definition and dependent variable definition is key to understanding how experiments work. The independent variable is what you change, and the dependent variable is what changes as a result of that. You can think of the independent variable as the cause and the dependent variable as the effect. When graphing these variables, the independent variable should go on the x-axis, and the dependent variable goes on the y-axis. Constant variables are also important to understand. They are what stay the same throughout the experiment, so you can actually accurately measure the impact of the independent variable on the dependent variable. Thank you for reading along with me, and hopefully you have a great rest of your day. Bye!